This is our submission for the dev post. This is a glasses that converts text to speech to text, sorry. So it uses an offline model called VOSC to convert speech to text. For the auditory impaired, because sign language isn't commonly taught, but most of them can read, and we just thought, why not do something for them? So this could actually be done. My team and I saw this competition 4 days to the submission, and we tried our best to put something together. And yeah, basically we came up with this, an offline speech-to-text glasses that project speech to the user in real time via augmented. It's like an augmented reality type of thing. Anyway, we didn't have so much time on our hands. We tried our best. Parts were difficult to get and everything, so we really love an extension. So over here we have a Raspberry Pi 02W, which is running a speech-to-text model, an open source speech-to-text model called VOSC. We have an I2C display and a mirror. The mirror mirrors the text onto this reflective HUD reflective lens. The ability to make this project a complete success if given the time. So for the sake of this demonstration, I'll be using the screen itself because the camera isn't very clear to reflect what is being said there, and it can't really get what's on the screen properly. So
okay, thank you very much for the video. Now we move on to questions. Daniel, if you want to turn on your camera so our judges can see you. Okay, I can see how much on my screen. So do you want to go first?
I believe Alex had his hand up first. Alex.
Oh, okay. All right. Thank you. Alex, please go ahead.
You're muted, Alex.
Alex, you're muted.
Well, there we go. Okay. Yeah,
Okay.
it'll be a quick one. I know you built this very, very quickly. So what are other things you would have added to it? And how has it been tested so far? My guess was that it was meant for perhaps people who have problem with their hearing, right? So have they tested it, and what was the kind of feedback you've gotten?
So well done, good day everyone. We haven't actually been able to test with actual users, although we did make modifications to the setup. And I think at the point of submitting in the finalists, we might have gotten the video mixed up, but we were able to make modifications to the setup. So this has a better, this is better in terms of production in what we've done previously. So what we're working on currently is more like a proof of concept. So we believe that with much time, we'll be able to build something that is a minimum viable product. But right now we're working with a proof of concept. Honestly, we didn't plan to make it this far. We just tried to do something that we knew was innovative. The goal of the final goal of this project is to get not just a one-way thing where just the auditory impaired individuals get the speech to text on their glasses, but also one for normal people who do not have that disability to be able to convert sign language to text as well for them. So we're still building, and we believe that with the effort we've been putting into it so far, we will be able to come up with something amazing.
All right, I'll go. That's been amazing work. That if that's what you were able to put together in like a week, that's awesome. My challenge is the weight and the bulkiness of the device itself. And I understand it's a prototype and you're going to be working on it. I have a few questions for you. Have you actually thought about building, just iterating on the model and forgetting about the physical prototype itself, because then if you could get a third-party device, I don't know, maybe the Meta glasses or some other device from China, and then you load in that model into that device, like to focus more on actually the AI aspect of it, of the speech to text and all that kind of stuff. And then also, if you're doing speech to text, if you go to India where people speak very, very fast and it's projecting in front of my screen, I don't care how, I can't read that. Like, it's just, now you're just going to make me have epilepsy and just throw up, because there's no way I can read that. So there needs to be some way for you to think about the functionality of the problem you're actually trying to achieve.
Right. So concerning the model question, yes, we have put some thought into it. Practically, we put in thought into the fact that there are multiple languages in Africa, and there are multiple dialects and accents that those languages are being spoken with. So we've actually put on our vision board specific accents and language tuning for the model that we are using, because it is something that is doable. But right now we went with this setup because of the context of the competition being in a constrained environment. So like you said, we could have hardware from China or the Meta glasses, or even some other open source glasses that are out there. But there is one thing that most of them lack, and that is onboard compute power. So most of the compute is shipped to a mobile device, and we are trying to create something that is completely offline. You don't ship to your mobile, everything is on your head. If you're in an environment where there is no network, there is no internet, it does not affect your ability to get what you're getting. So that is one thing. Then sorry, trying to remember the last question you asked.
That's fine. Lamek, go before the time runs out.
Thanks. I'm also just piggybacking a little bit on your question, because I wanted to ask how different is it from already existing products? Because even at Google I/O, they actually released a newer version of the same aspect. So what is the novelty in what you're trying to do? And
So
building the language model is one of it. Do you have the data set? Have you already looked at existing data sets? Because African languages are low resource languages, and this is one thing that the community has been grappling for over a lot of years. If you are aware, and are you aware of Masakane?
not really.
Yeah, please
But
check them out. They are building these data sets. Yeah.
all right,
So
thank you.
maybe you can answer the question of the novelty. What is the novelty of what you're trying to build?
Right. So, like we said, like I said earlier, this is not necessarily something that is new to technology, but the innovation that is here is that one thing we cannot look past is the fact that the economic situation in African countries does not necessarily make it easier for individuals to be able to get most of these high-end things. They cost somewhere around $500 to $1,000 for something really solid, and that's way more, like, seriously out of most African range, the budget. So we are going with something more budget-friendly, something more easy. So that is why we came up with something that has onboard compute. Now you have all the compute right on your face. Right now, the setup is really bulky, but we believe that with more nanotechnology, we'll be able to ship down the size. So what we have here is
yeah, we're out of time. So if you just want to quickly, round that up so that, yeah, thank you.
All right, thank you. So basically, the difference between this and what is out there is that we have the onboard compute power, and it's not shipping to your phone for extra compute.
Awesome. Thank you so much.